Hi everyone, I'm Lee, and this week on NASA Now, the need for speed, how the shuttle goes from 0 miles per hour on the launch pad, listen to this, to 17,500 miles an hour when it reaches orbit. And why does the shuttle fly belly first? That's ahead. But first, let's find out what's happening at NASA now. NASA's Space Shuttle Discovery is on the move as it gears up for its final trip. The shuttle made its way from the Vehicle Assembly Building to the launch pad in preparation for its 11-day mission later this month. It will deliver a permanent multi-purpose module to the International Space Station and also Robonaut 2, or R2, on its 39th and final flight. Now it's time to take a look at the past.
Space Shuttle Discovery was first flown in 1984. In 1990, it launched the Hubble Space Telescope, and in 1998, it carried the 77-year-old astronaut and United States Senator John Glenn, making him the oldest human being to orbit Earth.
The countdown is on for the next space shuttle launch. Joining us is guidance, navigation, and flight control engineer George Hatcher, who's going to tell us how the shuttle goes from Earth to orbit and home again.
3, 2, 1, 0. Liftoff of Space Shuttle and Lanes on a mission to build, resupply, and to do research on the International Space Station.
We ask this vehicle to do things that are literally out of this world. Things that you would never ask an aircraft or a car or a ship or a submarine to do.
We have booster ignition.
When it fires these rockets for those 8+ minutes to get into orbit, it's going from 0 miles an hour on the launch pad, straight up, which no car can do, to 17,500 miles an hour once it reaches orbit. Orbit is essentially continuously falling. By the time the Earth has pulled on me enough to fall towards it, I've actually moved to where it has to keep pulling me, and I basically just keep falling perpetually around the Earth. When I approach the International Space Station, our relative velocity, the velocity of the space shuttle versus the space station, is very small. I mean, we try to approach that thing almost at a walking pace for the last few moments before we dock. When you separate from the International Space Station and when you're docked with it, both of you are still going 25 times faster than a speeding bullet coming out of a rifle barrel. They do a nice little flourish around the space station so they can see every angle and then move a good distance away, turn around like we talked about before, and fire the OMS engines just to slow them down enough to where they start falling towards the Earth and interfacing with the atmosphere, and they start to come back in. And the whole reason we're doing this is because we've given this vehicle 17,500 miles per hour worth of momentum just to get it into orbit so that it can match up with the International Space Station. All of that kinetic energy has to be dissipated before we can fly it like an airplane, because we need to get it down to, say for instance, Mach 5, which is the threshold of hypersonic flight, before we can start nosing over and flying like an airplane. And we fly belly first because it presents the largest area possible to maximize the drag so that we can slow down with efficiency coming back into the atmosphere. And when we start flying like a plane, it's flying faster than an SR-71. It's flying faster than the cruising speed of a spy plane that can go from LA to New York in under an hour. But when it starts to fly like a plane, it's still a supersonic vehicle. And it's not until we get very far down in the atmosphere that the shuttle even has enough thickness in the atmosphere to be able to fly nose up like planes do. If you've ever seen a space shuttle land, it comes in nose down. It's one of the most frightening things to see if you've never seen it before, because you don't see planes normally dive straight towards the ground. The shuttle, not until it's only a few hundred feet off the ground do they do what's called the flare and actually start flying with an angle of attack like a plane does. But even then, they're still doing 225 miles an hour when they touch the gear down. and a passenger plane might be doing 120 to 150. So it even lands faster than a passenger plane, and that's one of the reasons we have to have those specialized rubber tires from Michelin that only exist for the space shuttle, because they can withstand going from 0 to 225 miles an hour in an instant. And it's going so fast, in fact, that that's why later in the program we added a parachute underneath the vertical stabilizer so that we can actually create the drag that we need to slow the vehicle down so that the brakes don't have to work so hard as we're coming to a stop.
Did you know that the external tank of the shuttle Discovery had to be repaired back in 1995 when woodpeckers made about 200 holes in the foam insulation on the fuel tank? NASA promptly installed noisemakers and physical deterrents to scare them off. Now you know.
Now it's time to check out what's up.
Check out this link for launch times and best places for shuttle sightings.
Today we learned the physics behind the launch and landing of the shuttle. Mind-boggling. Now it's your turn to put your know-how into action.
You and your classmates are going to compare the orbit of the shuttle to its ground track. We're excited to see your results, so email them to nasa-explorer-schools@mail.nasa.gov. To get started, check out the resources and activities on the NASA Explorer Schools virtual campus.
Well, that's it for NASA Now. Be sure to tune in next week when we'll learn about rocket testing. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.